3.7. In this lesson, we're going to evaluate determinants of matrices. Determinants are a number that we get from looking at a matrix. We only find determinants for 2x2 and 3x3 matrices. And our purpose for finding these numbers is so it can help us find a couple things. One, we can use a determinant to find an area of a triangle, which we'll see first in this lesson. And two, we can use determinants to solve systems of equations. So it's a different way of doing systems of equations without having to use elimination. It's also going to lead us into how to solve systems of equations using a graphing calculator, which is really neat, especially if you remember how long systems of equations could take when there's 3 variables. So let's go ahead and get started. This is telling us how to find a determinant. On a 2x2 matrix, it's pretty simple. All you have to do is multiply diagonally a times d, and then subtract c times b. Finding the determinant of a 3x3 matrix is a little harder. You have to extend the matrix a little bit, so when you've got your a, b, c, you rewrite the first two numbers, a and b. Do that for the second and third row also. The first and second numbers get repeated, d and e, g and h. The reason we do that is so we can multiply diagonally 3 times. Multiply those guys together, plus those guys, plus those guys. That's what we see down here. Then we have to do the same thing diagonally the other way, starting with g. Multiply diagonally, diagonally, diagonally. And once we get these two numbers, we subtract them. So a 3x3 is definitely more involved than a 2x2, but that's probably to be expected. So let's find some determinants. Part A, really straightforward. Some highlighters to color code. We multiply diagonally 5 times 1. Then we multiply diagonally the other way 4 times 3. We end up with 5 and 12. We subtract those numbers, -7. And the way we would label this is we would say determinant, just DET, of A equals a -7. Part B is a little more involved. We've got to extend the matrix, which means rewrite the first two terms in every row. And let's color code here again. I have to multiply diagonally, diagonally, diagonally. Once I get those 3 numbers, I add them together. So I'll do that first. Once you've added those together, now we're going to start multiplying diagonally the other way. So here's a different color. I'm going to go diagonal, diagonal, diagonal. And I'm going to multiply those numbers together and come up with 3 numbers also. End up with -9 plus 0 plus 8. And according to the formula on the previous slide, I want to add those 2 sets of numbers together and subtract. Once I do all that, I get 45. So I say determinant of matrix, I'll just call this matrix B, equals 45. So that's really the only new skill that we're going to learn in this lesson. All that's left is to apply it in a couple of situations. That brings us to our next formula. We can find the area of a triangle that's on a graphing grid by setting up the matrix as so. We plug in our 3 coordinates into a 3x3 matrix, and then we put some 1s here as some placeholders. Once we find the determinant of that whole matrix, we just multiply it by positive or -1/2. The reason we say positive or negative is because we want our area for our final answer to be positive. So let's take a look at what this looks like in a problem. Go ahead and pause the video, read over this, and see if you can set up the matrix. Don't forget to put the plus or -1/2 on the outside. Once you set up this determinant, don't forget to extend your rows by repeating the first 2 numbers. And if you haven't noticed it yet, you're going to start to love seeing the number 0 in a matrix, because there's a lot of multiplying that goes on in a matrix, and I don't know about you guys, but I love to multiply by 0. It's the easiest thing for me to do. So let's go ahead and set this up. I forgot my plus or minus here. I want my final answer to be positive. So let's take a look at what's going to happen. We're going to multiply diagonally. 3 times one way, 3 times the other way. And when we multiply that, we take the green numbers and add them up, take the blue numbers, add them up, and then subtract. Go ahead and pause the video, try that on your own, see if you get the same number as me. I get 1,515. I decide to multiply by the positive 1/2 to keep my answer positive, and I get 757.5. Let's see what our units are. Coordinates are measured in miles. This is an area, so miles squared. Don't forget to leave off your units. You don't want to lose a point for the easy part. And that's it. So I find the area of a triangle on a coordinate grid. We don't need to know the base and height, we just need to know the coordinates. You can go ahead and pause the video right now and try these on your own, or you can do that later. Now we're going to learn something called Cramer's rule. This helps us solve for x and y, or whatever our variables are, in a system of equations. These formulas are actually pretty convoluted and ugly looking. I won't make you memorize these formulas for a quiz or a test, unless I tell you otherwise in class. But my gut tells me I'm not going to make you. But you do have to be able to fill in the numbers. You have to know where to get the E, the B, the F, the D. You have to know how to find the determinant of A, and so on. You have to be able to, in other words, use these formulas. I won't make you memorize them, unless I tell you otherwise in class. So let's take a look at an example. We're going to set up the solving for this. First thing I like to do is find the determinant of A. Go back to your definition of how to find a determinant. If you don't remember how to do this, check it. Make sure you can come up with the same number I come up with. You have to be able to come up with this number on your own. Next, we're going to have to use this determinant along with a couple of other determinants to solve for x. For instance, if we want our x value, going back to the formula we just saw, we've got to use these formulas. We want to find out what the determinant of EB FD is, divide that by negative 57. I'm not going to show the steps on how to find the determinant for EB FD. You need to try it on your own. You need to make sure you know how to get it. Turns out that it's 114. So our x value ends up being negative 2. You've got to go through a similar process to figure out your y value using the formulas on the previous page. You're going to go AE CF over to the determinant of A, which we already know is negative 57. Turns out to get this determinant, you end up with negative 171, which is positive 3. So our solution is negative 2, positive 3. While this might not seem that much faster than using a system of equations, just want to keep reminding you that eventually I'm going to show you how to find determinants on a graphing calculator. You're going to be able to do these a lot more efficiently. You have to be able to do it using the formulas by hand as well, though. Next, if you thought those formulas were pretty convoluted, check out these ones. We've got to find a determinant of a 3 by 3 matrix twice, actually 4 times. We've got to find the determinant of A, then we've got to find 3 more determinants to find x, y, and z. This is a long process, but it's actually probably easier than solving 3 system equations the long way. If you don't remember those, go back and check your notes. I believe it was section 3.6. Again, I won't make you memorize these formulas unless I tell you otherwise, but you have to be able to use them. If you don't remember how to find a determinant of a 3 by 3, go back a few slides, review that. I'm not going to go through the whole process again, but I will give you the numbers. Go ahead and pause the video, read over this problem, and try to set up a 3 equation Three-variable equation. Looks like we're trying to find the atomic weight for carbon, hydrogen, and oxygen. So I can use three variables. I might use C, H, and O, except I will never use O for a variable. You can probably guess why. O looks a lot like 0. We don't want to get those mixed up. So instead of using an O, I'm going to just say, let's call that X. And I can set up three equations that way. I know that 6 carbons plus 12 hydrogens plus 6 oxygens all add up to an atomic weight of 180. I can follow this chart down and figure out the rest too. 1 carbon and 2 oxygen weighs 44. And 2 hydrogen plus 2 oxygen is 34. We're going to set up a matrix for this now. Using the formulas from the previous page, we can solve for our x, y, and z, except it's not x, y, and z this time. It's h. I should start with c. It's c, h, and x. And we've got messy formulas for all of them. Check back on the previous slide and try to use those formulas yourself. I expect you to be able to know how to use them on the quiz or test. After going through all these calculations, you should end up with carbon weighing 12, hydrogen weighing 1, and oxygen weighing 16. If you're having trouble getting any of those numbers, go back and study how to find a determinant of a 3x3 matrix. And if you're still having trouble, come see me. At this point, you can try these on your own, or you can do them later. That's it for this lesson.